Hi, welcome to another quick video, or hopefully a quick video. I'm estimating about 10 minutes to explain static equilibrium. So static equilibrium is about a mass that will be hanging from two wires or two cables, and the wires or the cables will be under tension at a particular angle. So I'm just going to sketch this out. I'm using a 60-30 set square, so I know that that will be 30 degrees. Slide it across like so. I know that that will be 60 degrees, like so. So we've written out a number of steps for us to follow. Free body diagram, write the equations, solve for B, substitute for A. So you're going to see how that works in a second. So basically, here's our 12 kilogram mass hanging downwards. This is going to be pulling on this cable and then pulling on this cable. So there's going to be some sort of tension. So we'll call that A and B. So the first thing we can do is look at this from the point of view of a free body diagram. So we're going to have a force acting downwards. We're going to have an equal and opposite force acting sort of upwards, but it's going to be a combination of the horizontal forces being equal to 0 and the vertical forces responding to the mass down. So we can use our trigonometry, and the first thing we do is we'll redraw this free body diagram just here, just to sort of clarify. So I've redrawn the diagram for us, and let's just go through this. So now we've got point in the middle. The mass due to gravity is the force downwards. I'm going to call that section C. There's cable B, which is a combination of a horizontal and a vertical. And then we've got A, which is a combination of a horizontal in the other direction and a vertical. So now we can resolve these forces. So free body diagram's done. Let's write out the equations. To do that, we will sort of do it as a set of columns. So we're going to do the sum of the F's, the forces, in the X, if you will. It's going to go equal to. So let's look at A. So put a title there. We'll do A, we'll do B, then we'll do C. So A is going to be, well, the angle 60 degrees, and we've got the adjacent, and we've got what effectively would be the opposite. And this is going to be the adjacent, that's going to be the opposite. So if we look at SOHCAHTOA, we're talking about in the X direction is the adjacent. Adjacent is cosine. So this must be A cosine 60 degrees. This is X in that direction. This is the X in that direction. So they're opposite each other. So that take away B cosine of 30 degrees. And then it would be plus or minus, whichever is appropriate. But you'll notice that there isn't a C in the X direction. There is no force from the object in the left or right. So that was just going to be a 0. The sum of all forces is equal to 0. So all of that, take away that, has to equal 0. Now I'm going to leave quite a big gap because I want to fill this space with a sort of this step here, solving for B, so that I can substitute for A. So down here I'm going to go the sum of all the forces in the Y direction, that's this way, so there's my X's, those are my Y's. Let's have a look. For the sum of all forces in the A, it's that one, it's the opposite, so it's the sine of the 60 degrees, so A sine 60. Now you'll notice that these are both going in the same direction, so it's plus b sine 30 degrees. And this is going in the other direction, so it's opposite, so it's take away the mass due to gravity. And that all has to equal 0. Now the technique here is to concentrate on one equation and try and resolve it out so that we've got A or B being equal to the other. So just try and sort of follow me along and you'll see how this works. I've got A cos 60 minus B cos 30 is equal to 0. If I want to remove this from this side of the equation, if I do the opposite, the reciprocal, if I do plus B cos 30 here, then I have to do plus B cos 30 here, and that would remove that, so I would end up with A cos 60 equals B cos 30. So that's my first step. So following the rules of algebra, what you do to this side, you do to the other side. Okay, now I want to get rid of the cos 60. It's multiplying here, so I would divide cos 60, which would leave me with A. And this side I've got to divide by cos 60, so I've got my B cos 30, and I can write it out like this, it's quite neat, and just do cos 60 like so. So now the B's on because the B would be multiplying and dividing by both. So we can put the B there and then do cos 30, cos 60. So now we can actually resolve that straight away. We've got A is equal to B times something, and we can get a calculator and we can do cos 30 divided by cos 60, and that gives us root 3, which is 1.732. So B would be times 1.732. 3 decimal places. Okay, so we'll keep working with that at the moment. So A is equal to B times 1.732. So wherever I see A here now, I can put B times 1.732. So let's do that now. So A sine 60, B sine 30. This will now be B times 1.732 sine 60 plus B sine 30 minus mass due to gravity equals to 0. So we can do some algebra. So one of the things we can do is if we add mg here, we get equals mg here. So that will be a fixed value, because remember these forces, that force has to equal that force. So that we could be doing that there. So the force on this side will equal the force in the opposite direction. So now we need to factorize. Okay, so we're at 9 minutes, so we've got a couple more minutes. Let's factorize B. 1.732 sine 60 plus sine 30 going to be equal to mg. So if we start putting some numbers into this, we'd end up with this being B times 1.999 is equal to, this is going to be 12 times 9.8, so that will be equal to 117.6. So that's times there, so I could go B is equal to 117.6 divided by 1.999 is equal to 58.9. So B is equal to 58.9, but what we also know is A here is equal to B times 1.732. So A now is equal to 5.89 times 1.732. So if we do that, 58.9 times 1.732. So A would be equal to 102. So force in newtons. So this would be, going back up here, that would be 102 newtons, and this would be 58.9 newtons. And that's how you do static equilibrium for a cable problem. I hope you find that useful, and I hope you do well in the exam.